Have you ever wondered how the human heart, a small organ in our body, keeps us alive every single second? This muscular marvel, roughly the size of your clenched fist, operates like the most efficient machine, tirelessly pumping life-giving blood to every corner of your body. It's a constant rhythmic dance, a symphony of contraction and relaxation, keeping us alive and kicking. The heart, my friends, is not just a biological powerhouse, but a symbol of life, love, and vitality. It's an organ that speaks volumes without uttering a single word. Through its ceaseless beats, it narrates the story of life, from the first heartbeat in the womb to the last in old age. But what gives the heart this extraordinary power? What's hidden beneath its robust exterior? What makes it tick, day in and day out, without a break? These are the intriguing questions we'll explore. In this video, we shall delve deeper into the intricacies of the heart structure. The heart, a fist-sized powerhouse, lies within our chest, tirelessly pumping blood throughout our body. This marvel of nature, the heart, is approximately the size of your clenched fist and located slightly to the left of your breastbone, protected by the rib cage. It's a muscular organ, resilient as it is vital, and its primary function, to serve as the body's circulatory system's core, pumping blood enriched with oxygen and nutrients to every corner of the body, and then bringing back the deoxygenated blood to be refreshed once again. A ceaseless cycle run by this incredible engine that keeps us alive and thriving. Now, let's take a moment to appreciate the sheer size of our circulatory system. Imagine a network of roads stretching for nearly 60,000 miles. That's more than twice the circumference of Earth. The heart in its lifetime pumps blood through this vast network, the equivalent of over 1 million barrels of blood, enough to fill more than 3 supertankers. And it accomplishes this monumental task with every beat, every second, every minute of our lives, without rest or respite. On average, it beats about 100,000 times a day, pumping around 2,000 gallons of blood. And it's not just about quantity. The heart also ensures the quality of the blood it pumps, removing waste products and carbon dioxide, and restocking it with oxygen and nutrients. The heart's role in the circulatory system is akin to a well-oiled machine, with each component playing its part. It works in harmony with the lungs, arteries, and veins, contributing to the overall functioning of the body. So the heart is really our body's engine, isn't it? But what exactly happens inside this engine? Our heart is a 4-chambered organ, each playing a distinct role in the circulation of blood. Let's begin with the top 2 chambers, known as the atria. To your left, you have the left atrium, and to your right, the right atrium. These are the welcoming chambers of the heart, accepting blood returning from the journey it's made around the body. The right atrium receives deoxygenated blood from the body through veins, and the left atrium gets oxygen-rich blood from the lungs. Now, let's move on to the lower 2 chambers, the ventricles. These are the powerhouses of the heart. The right ventricle pumps the deoxygenated blood it receives from the right atrium to the lungs, where it gets oxygenated. The left ventricle, on the other hand, receives oxygen-rich blood from the left atrium and pumps it out to the body, supplying our organs and tissues with the oxygen they need to function. Now, you might be wondering, how do these chambers not mix up the oxygen-rich and oxygen-poor blood? Well, there's a wall, called the septum, that divides the heart longitudinally. This ensures that the oxygen-rich and oxygen-poor blood do not mix, maintaining the efficiency of our circulatory system. Each of these chambers has a specific function, but they don't work in isolation. They operate in perfect synchrony, like a well-rehearsed orchestra. The atria contract first, pushing blood into the ventricles. Following this, the ventricles contract, sending blood to the lungs and the rest of the body. This coordinated contraction and relaxation, known as a heartbeat, happens around 70 times a minute in a resting adult. That's about 100,000 times a day. So these 4 chambers work in harmony to ensure blood flows smoothly throughout our body. But how does the blood flow between these chambers? Well, that's a story for another scene. Stay tuned, and we'll dive into the fascinating world of the heart's valves next. The heart's valves act as gatekeepers, controlling the flow of blood between the chambers. Our heart has 4 valves, each with a unique role in directing the flow of blood. They operate like one-way traffic systems, allowing blood to flow in the right direction, and preventing it from backtracking. Let's meet these 4 key players. First, we have the tricuspid valve, named for its 3 flaps or leaflets. This valve is nestled between the right atrium and the right ventricle. When the right atrium contracts, it pushes blood through the tricuspid valve into the right ventricle. Then, the valve closes to prevent blood from flowing back into the atrium. Next up is the pulmonary valve. Now, this valve is positioned between the right ventricle and the pulmonary artery, which carries blood to the lungs. When the right ventricle contracts, it forces blood through this valve into the pulmonary artery. After the blood has moved on, the pulmonary valve closes, stopping blood from returning to the ventricle. The third player is the mitral valve. It's found between the left atrium and the left ventricle. Similar to the tricuspid valve, the mitral valve opens when the left atrium contracts, allowing blood to flow into the left ventricle. Once the atrium relaxes, the mitral valve shuts to stop blood from flowing backward. Last but not least, we have the aortic valve. This is situated between the left ventricle and the aorta, which is the main artery that carries oxygen-rich blood from the heart to the rest of the body. When the left ventricle contracts, the aortic valve opens, allowing blood to flow into the aorta. Then it closes to prevent blood from flowing back into the ventricle. These amazing valves work in perfect harmony, opening and closing at the right times to maintain the one-way flow of blood. They ensure that our blood travels from the heart to the lungs to pick up oxygen and then circulates this oxygen-rich blood to every part of the body. So, these valves ensure that blood flows in the right direction. But what drives this flow of blood? The heart's beat, which you can feel as your pulse, is orchestrated by its own electrical system. Imagine if our heart were an orchestra. In that orchestra, the sinoatrial node, or SA node, would be the conductor. Located in the right atrium, the SA node is the heart's natural pacemaker. It initiates an electrical signal, setting the rhythm for the heart's beat. This signal is comparable to the conductor's baton, dictating the tempo for the rest of the musicians, or in this case, the heart's chambers. Following the SA node's cue, the electrical signal swiftly travels through the walls of the atria, causing them to contract and pump blood into the ventricles. But before the ventricles can contract, the signal must pass through the atrioventricular node, or AV node. The AV node acts like a gate, pausing the signal for a split second to ensure the ventricles have time to fill with blood. It's like the dramatic pause in music before the crescendo. And now, for the grand finale. The signal, once through the AV node, travels down the bundle of His and branches out into the Purkinje fibers. These fibers spread the signal throughout the ventricles, causing them to contract and pump blood out to the body. This is the powerful crescendo, the climax of our symphony. It's a rhythm that continues, beat after beat, day after day throughout our lives. But what happens if there's a glitch in the system? The rhythm can go off-beat, resulting in arrhythmias or irregular heart rhythms. Some arrhythmias are harmless, while others can be life-threatening. But don't worry, modern medicine has numerous ways to treat arrhythmias and keep our heart symphony playing on time. So, the next time you feel your pulse, remember the intricate electrical system at work behind each beat. The SA node setting the pace, the AV node holding the beat, and the Purkinje fibers spreading the rhythm, all working in harmony. So this electrical system ensures our heart keeps time, rhythmically pumping blood throughout our body. So, we've journeyed through the heart and unraveled its internal structure. We've explored the heart's 4 chambers, the right and left atria, and the right and left ventricles. We've discovered how these chambers work in harmony, ensuring the smooth flow of blood throughout our bodies. We've also ventured into the heart's valves, the tricuspid, pulmonary, mitral, and aortic valves. We've seen how these gates regulate and direct the flow of blood, preventing backflow and maintaining the one-way traffic of life-giving blood. Finally, we've illuminated the heart's electrical system. This intricate circuitry, invisible to the naked eye, choreographs each contraction and relaxation of the heart, maintaining our heart's rhythmic dance. In this journey, we've gained a deeper understanding of the heart's internal structure, revealing its complexity and elegance. Each beat of our heart is a testament to nature's engineering prowess. Next time your heart beats, remember, it's not just an organ, it's a marvel of nature keeping you alive beat by beat.